Okay, in this video we're going to look at the index laws. There are 6 index laws that tell you what to do when you've got different combinations of indices or exponents. So an exponent is something like this, 2 to the power of 3, and that means 2 times 2 times 2, so 2 times itself 3 times. This number here tells you how many times you have to multiply it together. Okay, so another example would be a to the power of 5. That would mean you have a times a times a times a times a. Okay, but the question arises, what do we do if we've got a to the 5 times a to the 3? How do we work that out? How do we find the answer to that? Or what if we had a to the power of 10 divided by a to the power of 7? What would we do with that? Okay, these index laws are going to help us work out what to do in these tricky situations. So let's look at the first one. Okay, the first index law is stated like this. If you've got something, we're calling a an unknown number. If you've got something to the power of x and then you multiply it by the same base but you've got a different power, then when you multiply those together, this is what you'll get. You'll get a to the x plus y. Okay, that's the first index law expressed there. All right, now let's do an example of that to illustrate better what it means. So let's say we've got 3 to the power of 4 times 3 to the power of 5. Okay, for the first index law, to multiply indices together, we need to have the same base. Okay, we've got a and a, so we've got the same base, so we can multiply these two things together using the first index law. If the base is different, if we had 3 to the power of 4 times 5 to the power of 2, we're not going to be able to use this first index law for that. We're going to have to work that out a different way because the bases are not the same, so we can't do that one. Okay, to do this one, 3 to the power of 4 times 3 to the power of 5, the law says you leave the base the same in your answer and you add the two indices. So here we had x and here we had y. We're going to add those together. So 4 plus 5. Okay, and we can simplify that. 4 plus 5 is 9, so we're going to end up with 3 to the power of 9. Okay, now we can check that that's true by working this out. 3 to the power of 4 was 3 times 3 times 3 times 3. And that was multiplied by 3 to the power of 5, which is 3 times 3 times 3 times 3 times 3. So we end up here with 9 3's multiplied together. Well, another way of saying 9 3's multiplied together is 3 to the power of 9, which is what we had from using the index law. So we end up with the same result, but the index law is obviously a lot quicker than going through this process. So that's the first index law. Okay, the second index law is kind of the partner to the first index law. The first index law was when we got to multiply two indices together with the same base. So let's say we had a to the power of 2 times a to the power of 3, we would get a to the power of 5. But the second index law is for when we've got a division between two indices with the same base. So let's say we had a to the power of x divided by a to the power of y. The second index law tells us how to deal with that. It says you do a to the power of x minus y. Okay, now note the order here. The x is the first part of the division. The a to the power of x is the first part of the division. So it's got to be x minus y. We can't do y minus x. If we had the reverse sum, a to the power of y divided by a to the power of x, then that would be a to the power of y minus x, because now the y is first. Okay, so that's the second index law. A to the power of x divided by a to the power of y is a to the power of x minus y. Let's do an example. Okay, let's say we had 3 to the power of 3 divided by 3 to the power of 2. Okay, the index law says we've got 3 in both cases, so of course the base is going to stay the same. The first power is 3 and the second one minus is 2. So I do 3 minus 2. 3 minus 2 can be simplified to 1, so we've got 3 to the power of 1, which we usually just write as 3. 3 to the power of 1 is just 3. Let's check that that's true. 3 to the power of 3 equals 3 times 3 times 3, and 3 to the power 2, if we're dividing it, so I'll put it underneath here, 3 times 3, that's 3 to the power of 2. Now, by simple cancelling, we can cancel out most of those 3's, and we're only left with 1 3 at the end, which is what the index law told us as well, that we just have 3 at the end. So we can see this index law works well. Okay, let's go on to the third index law. Okay, the third index law is a bit simpler than the first two index laws, but it's also a little bit harder to understand. It's easy to use, but hard to understand. The first index law says anything, whatever the base is, it doesn't matter. If it's to the power of 0, if it's raised to the power of 0, then it's going to equal 1. It doesn't matter what it is. If it's raised to the power of 0, it will equal 1. So that means 3 to the power of 0 equals 1. It means 100 to the power of 0 equals 1. It means this number, I'm just trying to come up with a big silly number, that to the power of 0 equals, you guessed it, 1. Okay, if I've got an unknown like x to the power of 0, that's 1. If I've got an unknown times an unknown divided by another unknown, and that's all to the power of 0, it's going to equal 1. Anything to the power of 0 equals 1. Okay, so how do I demonstrate why this is the case? Okay, I think the best way is to do it something like this. If we say we've got 3 to the power of 3, then we know that that means 3 times 3 times 3. If we've got 3 to the power of 2, we know that's 3 times 3. If we've got 3 to the power of 1, that's just 3. Okay, so I'm going down in my progression of indices. 3, 2, 1, 0 is the next one. Now, the pattern so far has been every time, and let's say this was 27, this was 9, and this is 3. Okay, the pattern each time is the answer from the previous number is being divided by 3. So 27 divided by 3 gives 9. 9 divided by 3 gives 3. Okay, so if we're going to follow that pattern, then this number 3 divided by 3 will give us 1. 3 divided by 3 gives 1. So one way to think about why we get, when something is to the power of 0, it's 1, is that it's following this kind of pattern. And that kind of pattern is going to be true for any kind of, whatever the base is. If it was 10 to the power of 3, that would be 1,000. 10 to the power of 2 would be 100. 10 to the power of 1 would be 10. And 10 to the power of 0, if we're going to continue dividing by 10, it's got to be 1. Okay, following that pattern, you always end up anything to the power of 0 equals 1. Okay, let's look at the fourth index law. Okay, here's the fourth index law. The fourth index law says if I've got some base a and it's raised to the power of m, and then that's in brackets, and outside the brackets the bracket has been raised to this other power n, then that's going to turn out to be this, a to the power of m times n. Okay, so this is maybe what you thought was going to happen when you had a to the power of m times a to the power of n. This is a first index law situation. You might have thought you'd end up with a to the power of m times n, but you didn't. You got a to the power of m plus n. Well, this is the one where you do multiply the powers together. It's when you've got the base with the power inside the brackets, and outside the brackets you've got another power. So let's see an example of that. Okay, let's say we've got 4 to the power of 2, and that's in brackets, and that's been raised to the power of 3. Okay, the index law says we do this. 4 to the power of 2 times 3. 2 times 3 is 6, so 4 to the power of 6. That's what the index law says we'll get. Alright, let's see if that works out to be true. So if we've got 4 to the power of 2, that's 4 times 4, and that's in brackets. And those brackets have been raised to the power of 3. Okay, so that means we've got to do whatever's in this brackets times itself 3 times. So that's going to equal this. 4 times 4 in brackets times 4 times 4 in brackets times 4 times 4 in brackets. Okay, we've done it 3 times, the 4 times 4. Okay, now the brackets actually don't do anything to this equation, so we can drop the brackets and we'll just have 4 times 4 times 4 times 4 6 times. Okay, 1 2 3 4 5 6. Well, another way of saying 4 times itself 6 times is 4 to the power of 6, which is what the index law told us. So the index law works. Fantastic. Let's go to the fifth one. Okay, here's the fifth index law. It looks kind of similar to the fourth index law, but it's not. It's different. The difference is inside the bracket this time we've got two different things, two different unknowns. And they're inside some brackets, and the whole bracket's been raised to the power of m. So before we had a power inside and a power outside. This time we've only got a power outside. Alright, let's put that into an example, see how it works. Let's say we had inside some brackets 3 times 5, and that bracket was raised to the power of, let's make it 4. Actually, that's going to end up being too long. Let's make it to the power of 2. Okay, so the index law says we're going to have 3 to the power of 2 times 5 to the power of 2. Okay, I've raised each of the things inside the bracket to that power outside the bracket, which was a power of 2. So you can see how it mirrors the format of the law there. 3 squared times 5 squared. Now let's check if that makes sense. And remembering this is going to come out to 9 times 25, which is 225. Alright, let's check it. So 3 times 5 to the power of 2 means 3 times 5 times 3 times 5. It's squared, so whatever's in the bracket's got to be multiplied by itself. That's what we've got there. Okay, well, 3 times 3 times 5 times 5. I've just rewritten this in a nicer way because the order of multiplication doesn't matter. 3 times 5 times 3 times 5 is exactly the same as 3 times 3 times 5 times 5 or 5 times 3. The order doesn't matter, it doesn't change anything. So I've just changed the order of the numbers. Okay, and here we've got 3 times 3, which is 3 squared, and that's being multiplied by 5 times 5, which is 5 squared, and 3 squared is 9, 5 squared is 25, so obviously we've got the same thing as we had earlier. We end up with 225. Okay, the fifth index law works. And this is obviously going to be the same, whatever you've got inside, whether you've got numbers like 3 and 5, or if you had letters like A and B, as we just saw. It's not going to change how the index law is applied. It's going to apply in exactly the same way. Okay, let's look at the last index law, number 6. Okay, the final index law is this right here. We've got a fraction inside some brackets, and it's that whole bracket is being raised to the power of m. That's going to give you whatever's on top of the fraction to the power of m divided by whatever's on the bottom of the fraction divided by m. Okay, let's put that into an example. Let's say we had 2 divided by 3, and it was raised to the power of 3. Okay, the index law says that's going to give us 2 to the power of 3 divided by 3 to the power of 3. 2 to the power of 3 is 2 times 2 times 2 is 8, and 3 to the power of 3 is 27. So it's going to give us 8 over 27. Let's check if that makes sense. So if we've got 2 to the power of 2 over 3 to the power of 3, then that's going to mean 2 over 3 times 2 over 3 times 2 over 3. Okay, when you're multiplying fractions, you do top times top and bottom times bottom. So that's going to mean we're going to have 2 times 2 times 2 divided by 3 times 3 times 3. 2 times 2 times 2 is obviously 2 to the power of 3. 3 times 3 times 3 is 3 to the power of 3. And obviously it's going exactly the same way as we had up the top earlier. we end up with 8 over 27. So there's the 6th index law. Works great, doesn't it? Alright, okay, let's go through a couple of quick worked examples and make sure we can apply these laws to anything that we come up against. Okay, the first one we've got here is 2 times n to the power of 4 in brackets raised to the power of 3. Okay, the index law that's going to apply here is, okay, to answer this question we're going to need to use the 4th index law. That was the one that said if you've got something raised to a power inside some brackets and then a power outside the brackets, you're going to have to multiply those powers together. So you're going to end up with a to the power of m times n. Okay, so let's apply that. We've got inside the bracket, we've got n to the power of 4, and that's got to get multiplied by this power of 3. Okay, but we can't forget about this 2 here. This is actually 2 to the power of 1. Any number, whatever it is, x, any mathematical entity, x is x to the power of 1. 5 is 5 to the power of 1. Okay, any number that doesn't seem to have a power there, it's actually to the power of 1. So we've actually got a 2 here as well. We've got to do 2 to the power of 1, and the 1 and the 3 got to be multiplied as well. So that's going to go at the front here. We're going to have 2 to the power of 3 times n to the power of 4 times 3. So we end up with 2 to the power of 3. N to the power of 4 times 3 is 12. So that's what we end up with, 2 to the power of 3, n to the power of 12. 2 to the power of 3, we should simplify that. That becomes 8 and n to the power of 12. So that's that one. Okay, let's try another one. Maybe a slightly harder one. Okay, this time we've got inside the brackets 3 times a squared times b to the power of 7, and that's all inside the brackets and raised to the power of 3. Okay, so it's this simple. We just got to go through each thing inside the brackets and raise it to the power of 3. So 3 is going to get raised to the power of 3. A squared is going to get raised to the power of 3. That's going to mean a 2 times 3, a to the power of 2 times 3. B gets raised to the power of 3, so that comes to 7 times 3. And let's simplify that. 3 to the power of 3 is 27. A to the power of 2 times 3 is a to the 6. And this becomes b to the 21. There we go. Done. Okay, here's another one. So this time we've got inside the bracket a fraction, and it's all being raised to the power of 4. Okay, so we've got to raise the top part to the power of 4 and the bottom part to the power of 4 in a new fraction. So the top part's got the 2, that's got to be raised to the power of 4, so 2 to the power of 4. X to the power of 3 is raised to that power, so that becomes x to 3 times 4. And then that's going to be all over y to the power of 4 times 4. Okay, let's try and simplify that. 2 to the power of 4 is going to be 16. And then x to the power of 3 times 4 is 12, x to the power of 12. And y is going to be to the power of 16. There we go. That one's done too. Okay, here's one more problem. It's good to work through. Now this isn't really covered by any of the index laws specially, although they do help. But the best way to work this one out is just to expand it out. Okay, because we've got a negative power inside that bracket, we need to know how many times it's going to be multiplied together, so we know whether it's going to come out positive or negative. If we had negative 4 to the power of 2, then the answer would come out positive because it would be a negative times a negative. With 3 powers though, it's negative times negative, which becomes positive 16, but then that's multiplied by another negative 4, so we end up with 64. 16 times 4 is 64, but it's negative because we've got a positive times a negative. So it's actually negative 64 we get in the end. Okay, let's summarize what we've learned about the index laws. Okay, so here's the 6 index laws, just written very simply. You need to copy these out. Anytime you see anything in these videos with a yellow box around it, that means that's something that needs to be copied out into your workbook. Okay, it's going to be important summary notes. So once you've copied those out, then you've got the 6 index laws. Just note with the 3rd index law that a to the power of 0 always equals 1, whatever a is, but a can't be 0. Okay, so it'll be true for every situation, whatever a is, but not when a equals 0. That's going to stuff it up. So there we go. I hope you enjoyed the video. Thanks for watching.